Question number 56. So in this you have been given the delta H naught combustion of solid benzoic acid at 27 degrees Celsius is minus X kilocalorie per mole, and you have to identify the delta E naught, that is change in internal energy in kilocalorie per mole. So first of all, tell me what is the relation between change in enthalpy and the change in internal energy. So it is equal to delta H is equal to delta E plus delta Ng RT. Delta Ng, I have already told you, it is a difference in the number of moles of gaseous products and the number of moles of gaseous reactants. So you have to find out first the value of Ng, then you can calculate the value of delta E. So first of all, write down the reaction of the combustion for benzoic acid. So benzoic acid is C6H5COH. So during the combustion, the products formed are CO2 and water. So now balance the equation. So सबसे पहले we will balance the carbon atoms. So carbon here are equal to 7, and now the hydrogen atoms are 6, so it will be 3H2O, and now the oxygen atoms are 17. So 2 are already in the reactant, so here will be 15 by 2. So benzoic acid is solid and oxygen is gas, CO2 is also gas, and water is liquid at the temperature of 27 degrees Celsius. So now first of all calculate delta Ng. So कितने gaseous products हैं? They are equal to 7 minus the number of moles of gaseous reactants, that is equal to 15 by 2. So it is equal to minus half. So now our work is very easy. So substitute the value in the first equation. So delta H naught combustion is minus X kilocalorie, and delta E naught we have to find out, and delta Ng is equal to minus half, so into value of R. So since you have to calculate the value of delta E naught in kilocalorie per mole, so R की value हम किस में लेंगे? Kilocalorie में. तो it is equal to 2 into 10 raised to the power minus 3, and into temperature in Kelvin. So it is equal to 300 Kelvin. So the delta E naught will be equal to minus X plus 0.3. So I hope this is clear to you. So option number 2 will be our correct answer. So moving on to the next one, students, we have question number 57, which says that the pH of the solution obtained by mixing 250 ml of 0.2 molar CH3COH, that is acetic acid, and 200 ml of 0.1 molar NaOH is. So first of all, we will write the reaction between CH3COH and NaOH. So we have been given 250 ml and 0.2 molar CH3COH. तो कितने मिलीमोल्स हो जाएंगे? So the millimoles will be equal to 50. अब similarly we will see for NaOH. So NaOH we have been given 200 ml and 0.1 molar. तो यहाँ पे कितने मिलीमोल्स हो जाएंगे? So the millimoles will be equal to 20. So the 20 millimoles of NaOH will react with 20 millimoles of CH3COH. तो यहाँ पे कितने बच जाएंगे after the reaction? It will be equal to 30. So all NaOH will be consumed and it will form the CH3COONA plus water. So here 20 millimoles will be produced for sodium acetate and water. So now you have in the mixture acetic acid and CH3COONA. So this mixture reminds you of the acidic buffer, because acidic buffer, I've already told you, is a solution of weak acid and the salt of its acid with the strong base. So for the acidic buffer we can calculate the pH, that is equal to pKa plus log of concentration of salt by concentration of acid. And the concentration of salt will be equal to millimoles divided by volume. So it will be equal to 20 divided by total volume कितनी है 250 plus 200. So it is equal to 450. And similarly for CH3COH it will be equal to 30 by 450. So the pK value you have been already given, that is 4.74 plus log of 20 by 450 divided by 30 by 450. So which is equal to 4.74 plus log 2 minus log 3. And log 2 की वैल्यू होती है 0.301. And log 3 value we have been already given, that is 0.48. So now calculate this. You will get the answer, that is 4.56. So option number 3 will be our correct answer. So moving on to the next one, you have question number 58. So it says that which of the following statements is incorrect. So the first statement says that weaker is the acid, greater is the hydrolysis constant of its salt with strong base. So let's suppose, so if you have a salt of a weak acid with a strong base, so hydrolysis constant का expression क्या होता है? KH equal to KW by KA, where KA is the dissociation constant of the weak acid. So अगर जितना ज़्यादा weak होगा acid, so the value of Ka will be very less. So value of Ka will be less, so the hydrolysis constant will be higher. So this statement is absolutely correct statement. So now you have the second statement which says that as temperature increases, the pH of pure water decreases. तो जब भी हम temperature को increase करते हैं, Kw increases. So as the value of Kw increases, pKw decreases and pH also decreases. So अगर हम 25 degree Celsius पे pH लेते हैं pure water का, it is equal to 7. So if we are increasing the temperature, the pH of pure water will be less than 7. So always remember this. So this option is also correct. So now you have in the third option, that is pH is an extensive property. So there are two types of properties. First is extensive and another one is intensive. And the extensive property depends upon the amount of substance and intensive properties depend only on the nature of substance. And the pH we can call it as an intensive property because it only depends upon the nature of the substance, whether it is acidic, whether it is basic, whether it is neutral, and it does not depend upon the amount of substance. So this statement is incorrect. Now you have the fourth option which says that on adding NaOH in basic buffer, its POH decreases. So the basic buffer comprises of a weak base plus salt of the base with strong acid. And if we are adding NaOH in the solution, means we are increasing the OH minus concentration in the buffer solution. And if the OH minus concentration is increasing, so the value of POH will decrease. So this statement is also correct. So the only incorrect statement, that is option number 3. So let's move on to the next one. So you have question number 59 which says that pH of a solution obtained by mixing equal volume of two solutions of pH 2 and 3 is approximately equal to. So you have one solution of pH equal to 2 And you know that pH is equal to minus log of concentration of H plus. So here the concentration of H plus will be equal to 10 raised to the power minus 2. And similarly in the other solution you have pH equal to 3. So यहाँ पे कितना हो जाएगा concentration of H plus? It will be equal to 10 raised to the power minus 3. So now these two solutions are mixed and you have to find out a new concentration of H plus ion. So you can use the equation that is M1V1 plus M2V2 equal to M3V3. So for the first solution the concentration is 10 raised to the power minus 2 into V plus 10 raised to the power minus 3 into V, and the final concentration you have to find out, and final volume is 2V. So the final concentration will be equal to 10 raised to the power minus 2 plus 10 raised to the power minus 3 divided by 2. So I hope this is clear to you. So now it is equal to 5.5 into 10 raised to the power minus 3. So now you have got the concentration of H plus, that is 5.5 into 10 raised to the power minus 3. So now you can easily calculate the pH. So the pH will be equal to minus log of 5.5 into 10 raised to the power minus 3. So you can write it like this, minus log of 55 into 10 raised to the power minus 4. So it is equal to minus log of 55 plus 4 log 10. And log 55 की value you have been given the question, that is 1.74. So it is equal to minus 1.74 plus 4. So the value will be equal to 2.26. So option number 1 will be our correct answer. So let's move on to the next one now. You have question number 60. So in this case you have been given the velocity of some gas molecules and you have to find out the ratio of average velocity to most probable velocity. So now the average velocity is equal to summation of number of molecules into the velocity divided by total number of molecules. And so you can calculate now the average velocity. So it will be equal to 2 into 2 plus 4 into 3 plus 3 into 4 divided by total number of molecules. So that are equal to 2 plus 4 plus 3. So it is equal to 28 by 9. And now you have to calculate the most probable velocity. So which is equal to the velocity acquired by most number of molecules. So the highest number of molecules are equal to 4. So the corresponding velocity is 3. So the most probable will be 3 meter per second. So now you can calculate the ratio. So the ratio will be equal to 28 by 9 divided by 3. So it is equal to 28 by 27. So answer will be option number 4. So let's move on to the next one now.